Atmospheric Experiments Laboratory and the Solar System Exploration Division at NASA Goddard. He's also participated for many years in the study of planetary atmospheres and development of space-qualified instrumentation, and he has many publications. Ladies and gentlemen, Dr. Paul Mahaffey.
Very much appreciate the invitation to talk here, and I'm going to follow up a little bit more on this topic of organics and also how it ties to the question that we're really pursuing. You know, was there ever life on Mars? If there was never life on Mars, why not? Is there evidence of past life on Mars, and so on? So I'm going to talk about MSL, which is the mission to be landed on the surface after Phoenix, but I'm going to get there a little bit indirectly. Wander around and talk a little bit about what we now think of the history of Earth and Mars. Talk about how we really get at this life question with looking for various biomarkers, whether they're in the atmosphere or in the surface. And then kind of the parameter space of missions before MSL and after MSL that will help us get answers hopefully to some of these questions. And then a little bit more specifically about MSL, which we hope to launch in a couple of years, and is the next really big rover on Mars. MSL just got named Curiosity, and I got to get in the habit of not calling it MSL, which is kind of the Dutch acronym, Mars Science Lab, but Curiosity, which a student won in a contest. Of course, telescopes are great things. Before telescopes, Mars in mythology was, of course, the Roman god of war, and temples were built in Athens. You can go look in honor of Mars. But then telescopes came along, and of course we started figuring out that the planets orbited around the sun, and Galileo, of course, made these wonderful telescopes. And once people started looking at Mars, they discovered things like the poles of Mars, Cassini, and Schiaparelli saw some features on Mars, and because of the quality of the telescopes, imaginations went a little bit wild, and he called these canali, these features, and actually, in fact, made up maps of them. And so early on with this idea of canali and possible water, of course, the idea that there might be other life on Mars and what it might look like, folks had to use their imaginations. Percival Lowell was somebody who pursued this, a good astronomer, but for much of his career tried to map this out. And of course, there was this 1938 radio drama where the invasions of the Martians was happening, and it scared the dickens out of all sorts of people. He's black and blue like a serpent, and so of course Hollywood picked up on this. And, just since 1964, just look at a few of the movies that involved Mars, classics like Santa Claus Conquers the Martians, and Mars Meets Women, and of course the one I really like, Total Recall, starring Arnold, who's now in California, and so on. But of course, these all featured kind of little green men who were not necessarily friendly to us. And of course now, the idea is we're not necessarily looking for bipeds or things with 4 legs or 6 legs, but really we want to understand, did primitive life, microbial life, ever develop on Mars? That certainly has been a driver for part of the program, but as you folks all clearly understand, getting to Mars is just extremely difficult. It's kind of interesting to go back and look at the history of human beings trying to get to Mars with robotic spacecraft. The Russians really put a huge effort into this, and of course the space age was just coming. A lot of failures, but of course understanding how to do rocketry and get things into space was also kind of in its infancy. So I kind of color-coded here the failures, either launch failures or cruise failures, and there's a lot of red. There's a couple of yellows in here, just a bit of data came back from launches in 1971. U.S. started a little bit later than that. First there was a failure, then 64 and 71. Some partial successes. Mariner 9 actually got to map the planet a bit, and darn, there were no Canelli, but you know, it looked pretty dry, no liquid water, but volcanoes and valleys and lots of other good stuff there. 1973 campaign, again mixed. Mars 5 orbiter lasted a bit. Mars 7 lander got some descent data, but didn't get any from the surface. So if you kind of look at pre-Viking, if you're keeping score and you figure that Mars is up to get spacecraft, the home team there had 14 and the visitors kind of had 2. It's really kind of an amazing statistic. But then 75 came along, and the Viking landers, and just amazing how rapidly our understanding of how to get to space and land on another planet had progressed. Just an amazing vehicle. Two Viking landers landed successfully on the surface. Jerry Soffen is shown here, the project scientist, and there's a picture from Mars kind of showing this rocky, deserty place, and imprint from the arm, similar to what Frank described for Phoenix. And by that time, the missions really were looking for life. They were looking for microbial life and to set up some experiments to do that specifically. And I'll just talk a little bit about one, this gas exchange experiment that was referred to. Gil Levine was the principal investigator on that, where they put some water and a nutrient, mixed it with soil, and they looked for a response to see if microbes would be metabolized into soil, and kind of got what looked like a positive result. And however, there was a gas chromatograph mass spectrometer on board, and the thought was, well, if you really had microbes and organics, when you heated things up, just like TIGA did on Phoenix, you should be seeing organics. And they really didn't see any. The instrument was working well. They saw backgrounds from the instrument, but no organics. And so that kind of put the exploration for life into a bit of a doldrum for quite a while, quite a few years. Although the exploration of Mars continued, the Soviets were successful with Phobos. Mars Pathfinder was kind of one of the first of these NASA smaller, faster, cheaper rovers, and the little yellow guy smiling there, it worked and got some data back, some elemental composition of the rocks. And then a bummer, there were a couple of failures that Fred talked about as well with the polar lander and the Mars Climate Orbiter. But Mars Surveyor got there, and this set of data is really what I think has really turned our understanding of Mars around. It's from an instrument called MOLA that basically sends a laser beam down to the surface, measures the time it takes to get back to the spacecraft, and so it maps out the surface topography of Mars. And it's just amazing what level of geology you can do with this type of data, and also combined with high-resolution imaging from Mars. And so we've really transformed our understanding of Mars based on the recent set of spacecraft results. Japan got into the game a bit and had a failure with their first Mars mission. ESA sent up a mission which was really successful, Mars Express. They had this really wonderful stereo imager on it, and here's one of the really interesting images of these kind of pillars of salts. And what really also has transformed Mars, it started with Mars Express, the European spacecraft, was doing spectroscopy for Mars orbit. If you take an infrared spectra of a rock, for example, you get a certain pattern coming back, and nobody really knew whether Mars would be so totally covered by the dust storms and everything that you really could see differences. But in fact, it turns out you can see differences, and you can really identify, if not really specific minerals, at least classes of minerals from Mars orbit. And so that started with the ESA missions, and then in particular a mission that's now working very well, a NASA mission, Mars Reconnaissance Orbiter, is continuing to do that, getting both very, very high spatial images. You saw those images of stuff on the surface of the Phoenix lander, for example, and also this really beautiful spectroscopy. And so our understanding of Mars from orbit is just tremendously improved. Brett talked about this mapping of the hydrogen, another fundamental result. And then, of course, came the MER rovers, which were just an incredible success, landed with their balloon air base, deploying, bouncing around the surface, rolling to